All right, let's talk about a really big shift happening in AI right now. We're at this moment where AI is evolving from a simple assistant into something more, an autonomous, digital worker. And this new idea, called Agentic RAG, well, its success pretty much hinges on one critical piece of the puzzle, the database. So let's dive in and figure out what that really means for you.
So what's the actual difference here? Well, think of the old traditional RAG as a one-way street. You ask a question, it fetches a document, it spits out an answer, end of story. It's a passive assistant. But Agentic RAG, that's a whole different ballgame. It's this dynamic, looping process. It's a proactive partner that can actually plan things out, use a bunch of different tools, and even double-check its own work before it gets back to you.
And let's be clear, this isn't just some minor update. It's a fundamental change in how these systems work. The heart of Agentic RAG is these intelligent agents that do way more than just retrieve information. They can actually reason through a complex problem, come up with a multi-step plan, and decide for themselves which tools they need to get the job done. You know, it's kind of the difference between a librarian who finds a book for you and a full-blown research assistant who finds the book, reads it, and then writes the entire paper for you.
So what's under the hood? What gives these agents their superpowers? Well, first off, they have memory, both for what they're doing right now and for things they've learned in the past. They can actually create a strategy to solve a problem. They have this thing called function calling, which is really just a fancy way of saying they can use outside tools like searching a database or the web. And maybe the most important piece of all, they can self-correct. They can check their own work. That is what makes them truly autonomous.
To really get why this is such a huge deal, we have to look at how the role of the database has changed. You know, in the old systems, the database was basically just a static library. It was a digital filing cabinet. You'd go in, look something up, get your answer, and that was it. Just a passive collection of information waiting for someone to ask for it.
Yeah, that's just not going to cut it anymore. For an AI agent, the database isn't a library. It's a dynamic tool. It's one of the most important tools in its toolkit. It's the agent's eyes and ears, you could say, giving it the information it needs to make smart decisions. An agent might hit its database tool, then use its web search tool, then come back to the database, all in a single thought process to build out a complete answer.
And as you can imagine, this new job puts some serious, and I mean serious, demands on the database. It can't just be a one-trick pony. It needs to handle really complex queries, mixing vector search with old-school metadata filters. It absolutely, positively must have powerful hybrid search built right in. And it has to juggle all sorts of data, from unstructured text documents to perfectly structured tables, all at the same time.
So that's the challenge. The big question is, how do we actually build systems that can meet these crazy new demands? Well, luckily, the industry has come up with three main ways to tackle this. Three core architectural patterns. Each one has its own pros and cons, and they're good for different situations. Let's break them down.
First up, you've got the specialists, the purists. These are the dedicated vector databases. We're talking about tools like Pinecone, Weaviate, and Milvus. These things are built from the ground up for one job and one job only, storing and searching through billions of vector embeddings at lightning speed. If raw performance and scale for vector search is your #1 non-negotiable priority, these are the tools you look at first.
The second path is all about building on what you already have. This is the world of hybrid relational databases. And the poster child for this approach is, of course, PostgreSQL with the pgvector extension. The idea here is simple. Take the familiar, battle-tested database your team already knows and loves, and just add vector search superpowers to it. All your data, your regular structured data, and your new vectors live together in one happy place.
And our third category? Well, it's the evolution of a classic, the big search engine platforms. Tools you've probably heard of, like Elasticsearch and OpenSearch. These have grown far, far beyond just keyword search. They're now these massive, comprehensive data platforms with incredibly powerful vector search built right into their core. For many big companies, they're the all-in-one solution for doing RAG at an enterprise scale. Okay, let's put them all side by side so you can really see the trade-offs. The dedicated vector DBs, they're all about that raw, specialized performance, but they can sometimes add a bit of operational complexity. The search engines, they are the undisputed kings of integrated, powerful hybrid search, making them a natural fit for the enterprise. And the hybrid relational approach with Postgres, its strength is simplicity and having that unified data store, which is just fantastic when you're getting started or prototyping.
Now, you've heard me say hybrid search a few times now, and for good reason. It's not just some nice-to-have feature or a buzzword. For any serious agentic RAG system, it's pretty much a non-negotiable. It's a strategic necessity. So why? Why is it so darned important?
It's because neither type of search is perfect by itself. Pure vector search is amazing at understanding context and meaning, but it can be terrible at finding specific exact terms like a product code, a person's name, or a technical term like LLMA. It might just glide right over it. On the other hand, old-school keyword search will find that exact term every single time, but it has zero understanding of context. Hybrid search gives you the best of both worlds, the precision of keyword search and the contextual understanding of vector search.
So how does this magic actually work? Well, one of the most popular techniques is called reciprocal rank fusion, or RFR, and it's way simpler than it sounds. Step 1, you run your regular keyword search and you get a ranked list of results. Step 2, you run your vector search and you get a different ranked list. Finally, you just combine those two lists using a really simple formula to create one unified, much more relevant final ranking. The best part? There's no complex manual tuning needed. It just works.
Okay, we've gone through the what and the why. Now we get to the most important part of all, the part that really matters. How do you actually pick the right tool for your new digital worker? So let's get practical. Here are 3 clear recommendations based on what you're trying to build.
Okay, first scenario. Let's say you're just starting out. You're building a prototype, or maybe it's a small to medium-sized project. In this case, the recommendation is crystal clear. Start with PostgreSQL and the pgvector extension. Why? It's super cost-effective, your team can use all the SQL knowledge they already have, and honestly, having all your data in one database just makes development so much simpler.
Now let's change gears. What if you're building a mission-critical application for a large enterprise? The priorities shift. Here you should be looking very seriously at mature search platforms like Elasticsearch or OpenSearch. They have incredibly advanced hybrid search right out of the box, they come with all the security and monitoring tools big companies need, and they have a long, proven track record of scaling to handle just massive amounts of data.
And finally, scenario number 3. What if you're building a cutting-edge AI-native application where performance is everything, where every millisecond of latency matters? In that case, you need to go with a purpose-built, dedicated vector database. Whether that's a managed service like Pinecone to get to market fast, or a powerful open-source option like Weaviate or Milvus for total control, these tools are fine-tuned for the absolute lowest latency and the highest possible throughput.
At the end of the day, this whole shift to Agentic RAG is about transforming AI from that passive assistant into a proactive digital worker. And just like any worker, human or digital, its ability to do a good job comes down to the quality of its tools. The database is the most fundamental, most important tool you can give it. So the only question left is, what tools are you going to give yours? Thanks for watching.